In the name of God and hi to all students. In the previous sessions, we talked about the linear, some examples about the linear classification. The last example was about the XOR, and we said that in some data, one line is not enough for classification, and we need, for example, for this example, for this data, we need two lines. And sometimes in data, linear classification cannot segmented, cannot classify the data, and we need nonlinear classification. Then we refer to neural networks, and as you heard before, or maybe this is new for you, in our body, for transforming some signals to brain, there are some special cells. We call it neuron, and a neuron is the main body, and the main body has some dendrites and then axon, and at the end they have terminals. Okay, and a signal comes from here to arrive to dendrite, and then pass along axon, and then pass through the terminals. Okay, this cells is a neuron cell, and the numbers of neurons in our body is too high, and this is the neurons of some kind of bird. This so interesting. For bird also, the neurons have some axon, dendrite, and terminals. Okay, and in this book, this diagram is so interesting because they said that a neuron is like this circle, and if the amount of a signal is in this gray area, then the neuron doesn't activate it, and then we don't know, we don't have any outputs. But if the amount of signal is in this area, in this orange area, then we have outputs. Okay, these areas, gray area and orange area, can be drawn like this in this diagram. If the amount of input in this area, then we don't have any outputs, and if the amount of area the amount of input is in this area, then we have outputs. Okay, we called this function in neural networks, we call it activation function, and we have many activation functions. For example, another famous one is sigmoid function. sigmoid function is a kind of activation function with this equation. Okay. For example, if we have a neuron in the neural networks like this, and we have 3 inputs, we calculate the summation of the input A, B, and C, and then pass through the sigmoid function, and then finally we have the output Y. Okay. Now in this diagram we can see that if we have signals, for example in the left, and you can see it in the yellow arrows, okay, then they pass through the dendrite, then axon, then terminals. Then the outputs of the terminals arrive and reach to the another dendrite, then pass through the axon, then pass through the dendrite, terminals. Sorry. Then the outputs of terminals reaches to dendrite, and then pass through the axon and then terminals. And this event happens for different neurons. But how we can model these events in computer? We can consider each neuron like this, like we called it in neural network a node. And then we have layer 1, layer 2, and layer 3. And we have inputs of signal. The signal reaches to the neurons, and then pass through each neurons and arrive to the second layer, and then the outputs of the layer 2 arrives to layer 3, and then finally we have the outputs. The brain said that what to do, for example, okay? But what is the relationship between the neurons? We can see these green arrows shows the connections, the relationship between each neurons. In fact, all the connection is not as the same. All the connections are not at the same. For example, maybe this neuron affects more a neuron 1 in layer 2 compared to the neuron 2 in layer 2. Okay, then how we can present these properties? We can put a rating, a value in each connection, and said that okay, the outputs of neuron 1 multiplied by W11, and then achieve to neuron 1 in layer 2. And please attention to the number of each weight. W11 is the connection between neuron 1 and neuron 1. Again, W11 between layer 2 and layer 3, neuron 1 of layer 2 and neuron 1 of layer 3. Okay, and maybe they are as the same, or maybe they aren't. Okay. Now consider simple, very simple neural network with 2 layers and 2 nodes in each layer. The connection is like this. We have inputs and we want to calculate the outputs. Okay. Consider the input is 1 and 0.5. Okay. And for example, if the weighting values is like this. Okay. And again, in this diagram, you can see better. Okay. The layer 1, always the first layer, the nodes in layer 1 don't have activation function, because we called the first layer the input layer. The first layer only get the inputs and then transmit it to other layers. Then the first layer doesn't have any activation functions. Okay. Then how we calculate it? Then the value of node 1 in layer 1 is 1. 1 multiplied by W11 and reach to the neuron 1 in layer 2. On the other hand, the value of node 2, 0.5 multiplied by W21, and again it reach to neuron 1. Okay, they sum to each other, and then imagine the activation function of this node is sigmoid. Then we put it in the mathematical equation of sigmoid, and then finally we have the first output. And this exactly repeat for the other connections. Okay. And you can see here A multiplied by WA, B multiplied by WB, C multiplied by WC. We calculate the summation of them and then pass through the sigmoid function. And finally, we have the output. And here also you can see the output, how we can calculate the input by the weights. Okay. Anyway, the first output after passing the sigmoid is this. You yourself can calculate yourself. This is so simple. And the second is this. Then in this diagram you can see the outputs. Now another thing is that this neural network is so simple, but if we have, for example, 100 nodes in each layer, for example 20 nodes with 5 layers, then this is too time consuming that we step by step multiplied this value and then multiplied another value with this weight and then sum calculate the summation and pass through the sigmoid. It is not too, of course it is too simple, but it is time consuming. Then in this way we try to use the matrix. You know the matrix, the operation of the matrix. Okay. Besides, in computers, the matrix is defined in most of in all softwares. Okay. Then in these pages, the books explain about the multiplying two matrix, how we calculate, for example, first row multiplied by first column, 1 multiplied by 5 plus 2 multiplied by 7, and this is the result. Okay, just too simple. Then we can, for example, for this simple neural network, we can write it in the form of matrices. The first matrix is related to the weighting matrix, and it is the size is 2 by 2 because the number of nodes in each layer is 2, and we have 2 layers. Okay, and the inputs are can be written in the vector matrix. And now we can calculate this multiplication, W11 and W21 multiplied by input 1 and input 2. Okay, like this multiplied this, then W11 multiplied by input 1 plus W21 multiplied by input. Okay, then again, according to this matrix representation, you can calculate the output of each node. Of course, the output of this node before passing to the activation function. We multiply the input and weights, and then after that pass through the sigmoid. Okay, then totally we can say, okay, the x is equal to W multiplied by I is input, W is weighting matrix, and x is the calculation of this equation. Okay, and then after that the output of each node is the sigmoid of the x. Okay, for this session it is enough. And if you pay attention in this discussion, I explained about 30 pages of Rashid book, and then in each session I try to explain only 30 pages, and it will be finished soon. I ask you to study these pages yourself. It is too simple, but with high concept. Maybe you can see the activation function in other books, in other references, but you see the Rashid book explain this concept so simple, and it is so good for understanding. Okay, thanks for your attention, and If you have any questions, please prepare it and ask it in a Telegram group or in online classes. Bye to all.